Hey guys, we're back here with another hard SAT problem that we're going to solve, and I'll show you how to solve this one really easily. But first, let's start off with another joke. Why do plants hate math? It's because it gives them square roots. Okay, that one is pretty funny. Let's start off by, like always, identifying our givens and what they're asking for. As you can see in the question, a square is inscribed in a circle. The radius of the circle is 20 times the square root of 2 over 2 inches. What is the side length in inches of the square? Well, our first given is that we have a square that's inscribed inside of the circle. Our second given is that the radius of the circle is 20 times the square root of 2 over 2 inches. Now, what is the side length in inches of the square? With questions like these, especially in geometry and trigonometry, it's best to draw them out. So we'll do just that. So let's draw the circle, since that is a shape that encases the square. Now, because it's a square, let's just label that all these sides are the same length. The radius of the circle can be defined as any point from the circumference of the circle to the center of the circle. But for the purpose of this problem, we're going to label the radius as where the vertice of the square touches the circumference of the circle to the center. This will be useful later on. Let's label this as 20 times the square root of 2 over 2. Now let's draw a couple lines real quick. Now we know that this right here, we can draw a line from the center of this side to the center of the squares. And then let's do the same thing from the center of the bottom to the center of the square. If you notice, this actually creates a little mini square with half the length and half the width of our original square. However, if you notice, the diagonal of this square is actually the same thing as our original radius of the circle, because as you can see, it still meets the definition of a radius by stretching from the circumference of the circle to the center of the circle. So this is also 20 times the square root of 2 over 2. Now, how do we find this length right here? Well, we know because this mini square is also a square that these four are equivalent as well. Now, because these four are equivalent and there's a line that creates the diagonal between the opposite two vertices, this square is actually split into two separate triangles, as you can see. Each of these triangles have two equal sides, and they are right triangles as well, because squares have right angles. Now, this can also be identified as an isosceles right triangle, or better known as a 45-45-90 triangle. These are one of the special triangles, and they're special because they're pretty easy to solve. One of the properties of a 45-45-90 triangle, or triangles that look like this, is that if one side is labeled x, then the hypotenuse is always going to be x times the square root of 2. Now, this is important because the hypotenuse of this 45-45-90 triangle corresponds to the hypotenuse, or the diagonal, or even the radius of this circle. They're all the same thing. We know that this dimension is 20 times the square root of 2 over 2, as we established earlier. So this can be expressed as the side length times the square root of 2, as you can see right here from this formula. So x times the square root of 2, with x representing the side length of the small square. So x times the square root of 2 is equal to 20 times the square root of 2, all divided by 2. To get x by itself, we want to divide by the square root of 2. But because there's a square root of 2 right here, and also being multiplied in the numerator, we can actually just cancel them out. So now all we're left with is x is equal to 20 over 2, or 10. We know that this side right here is equal to 10. Now, do you remember how we got this side by drawing a line from the bottom of the square to the center of the square? Well, that means that this line would be half the length of this line right here, or half the length of the total side length of the square. That means that the total side length of the square is double this, which would be 10 times 2. So s, or the side length of the square, is equal to 2 times x, or 2 times 10. That means that our final answer is s, or the side length of the square, is equal to 20.